Well, thank you for the introduction, Dan. Glad you guys all made it back into the session. The opening session was fantastic, and we're really looking forward to a couple of great days here at the International Seating Symposium. So thanks for coming. Brad and I are going to share with you a concept paper that we hope will be a valuable tool in your clinical settings. Optimized wheeled mobility device recommendations with CLOUT. And what the CLOUT document is, the clinical limits of use tool for wheeled mobility devices. So we want you to become familiar with what that tool will be, to be able to identify 3 sources of objective information to support the work that you're doing in your clinical settings related to this particular topic, to be able to discuss 3 limits of use of Group 2 power wheelchairs. So we know that most of you are familiar with that kind of technology. We want to be able to bring it into the context and put it into identifying limits of use to move forward in those recommendations for wheeled mobility devices. And then finally, to outline the general process for applying CLOUT to any type of area of medical devices and technologies. I'd like to just acknowledge that, we come up with some of these ideas, like what the heck are they talking about this time? And a lot of you have the same type of experience of over the years having conversations with colleagues, collaborators, clients, and we mull things over and try to think about how we're going to improve our practices and take care of our folks. So I just wanted to acknowledge my VA colleagues and of course our partners at the University of Pittsburgh and the Human Engineering Research Labs, where we have been talking about these types of topics and thinking about how we can create a model and a framework to support your clinical practices. So I won't go through all of them, but I sincerely appreciate the collaboration with all of these people that are listed. We, at the National Center for Patient Safety, where I work, that's based in Ann Arbor, Michigan, with a VA National Program Office, we entered into a partnership with the Human Engineering Research Laboratories with the University of Pittsburgh in kind of just a collaborative project. And there were 2 outcomes with this collaborative project. One was the clinical limits of use tool for a process guide, and again, that's outlining the medical devices and technologies approach for any type of technology. And then secondly, the guide that we're really going to focus on, of course, with this audience is that CLOUT model specifically applied to wheeled mobility and seating technologies. At the end of the presentation, and you'll have it in your handout as well, is the website where you can download from our National Center for Patient Safety with the VA the PDF document. You can also Google CLOUT wheelchairs, and it will pop up as your #1 pick. So we're happy to see that. So moving right into this document, this ended up being a compilation that ended up being about 50 pages or so, and we have no intention of going through all of those. But as you look at the sections and the breakdown, you will see its very strategic approach. And the way that we designed this was, we encourage you to sit down and kind of read through it, beginning to end at some point. It doesn't have to be all at once, but beginning to end really gives you a context of how the framework for working together with this topic is developed. And then you can go through and use each of the different sections as its own standalone resource. So when you see the section on manual wheelchairs, you can then go back and say, here's the section on manual wheelchairs, and I was looking for information on Group 4 power wheelchairs. Let me see what's here, and reference that independently. So we'll go through some of these sections, and again, in the document, you have a comprehensive bibliography of 50 to 60 different references that supports all of the work. So everything is cited, and we're really proud of this evidence-based approach that should be helpful in your clinical applications. So here I'm going to hand it over to Dr. DiCiano, and he's going to give you an outline of the framework for the CLOUT model. Here you go, Brad.
Thanks, Kendra. Can you all hear me okay? Great. So how many people have heard of the ICF model? Great, so a number of people. For those who don't know the ICF model, it's a model that was developed by the World Health Organization, and it's something very helpful to become familiar with if you're not already. It's a way for us to think about a client comprehensively. So the idea is that a person has a certain health condition, let's say, for example, tetraplegia from a spinal cord injury, and that medical condition affects the person's life in a number of ways. One is by affecting body functions and structures. So for example, the tetraplegia might cause scoliosis and difficulty with positioning, or predisposition to pressure ulcers. It also may affect the person's activities, such as walking, for example, or the person's ability to participate in certain activities, such as employment or school. And we have to think about somebody's condition in the broader context of the person's personal factors or characteristics, the things that are important to them in their own life, as well as the environments that they're going to be moving in and out of. So for example, ways that we can apply the ICF to a wheeled mobility device user is to look at all the different ways that we can use the ICF model to think about the wheeled mobility device being used in different categories. This is the framework that we use to develop the CLOUT model. So for example, when we're thinking about a wheelchair, we might think about the way that the wheelchair can support certain body functions and structures like postural support or preserving skin integrity. And again, the environments that the person's traversing through are extremely important. So we always need to consider how a person's life goals and environment really factor into the use of the device. This is an example of how we develop some visual models within the CLOUT document to help you categorize devices and see where they can be used in certain areas. So up at the top of this diagram, we have body structures and functions, activity factors, environmental factors, and on the column on the left, we have different device features. So let's say, for example, your client needs postural support, or they need the ability to relieve pressure to prevent a pressure ulcer. The table will allow you to see which device features can actually help with those body structures and functions, or activities, or environmental factors. So it's a way to just get an overview of how the ICF applies to different devices and their features. How many people are familiar with the Wheelchair Service Provision Guide published by RESNA?
Good, great.
Great, a lot of people. So this is a really useful guide that's available on the RESNA website, and it outlines best practice in the way that we provide wheeled mobility devices to our clients. So it's a process. It starts with the assessment. It goes through equipment procurement and selection. And those two first circles represent the area where our CLOUT document applies. So we're going to be talking about the limits of use of devices during the assessment and matching the device with the person. But of course, the process goes beyond that. There's funding and procurement. There's product preparation, fitting, training, and delivery, and so forth, all the way to the end where we measure outcome measurements and refer the client. So the CLOUT really gives us a way to define the limits of use of technology along the wheelchair service provision pathway. And so now we'll move into the product quality and safety part of the discussion.
Yep. So again, this is the way that the framework is organized. You're gonna, if you look at everything beginning to end, and then you go back and go, hey, I forgot about that key component of how these devices are regulated, or where my components are for establishing quality and safety recommendations for the individual. You can then go back to the particular section on quality and safety with these products. You know, when it comes to wheeled mobility devices, you know, I've been working in this field for more than 25 years, and I now work for the VA National Center for Patient Safety, and people go, wow, you work in safety now. Kendra, do you miss wheelchair stuff? And I'm like, wow, I do wheelchair stuff all day, every day. Because everything that we're working with in technology or in rehabilitation is always about safety or includes safety. So we're really supporting people to do what they want to do in their everyday life, and of course, while keeping them safe. We don't want injuries to occur for them or for their caregivers along the way. So when we look at in our national databases, and we have access to a lot of information, what are the types of safety issues that we see are reported surrounding wheeled mobility devices, and they're broad and they're varied, but some of those issues can be injuries, and they can range from minor to catastrophic. So of course, an individual that might sustain an abrasion or a bump or a bruise is one thing. Of course, with the population that we work with, that can then further decline into something significant like a pressure injury or a deeper injury. We hear things about fractures, people experiencing a fall or having an adverse event moving into something and having that type of issue occur to them. And in the worst case scenario, we do deal with investigations and evaluations related to deaths that occur as a result of an accident related to the use of wheeled mobility devices. And so of course, worst case scenario, we're looking into these types of issues. Falls are extremely prevalent, so working in the realm of safety, it's, across the country in the Veterans Health Administration, we hear about falls all day, every day, and are really looking at putting systems in place to address those issues and to support the resolution of those issues so that we can learn techniques and opportunities to prevent those issues. Very common, people can fall from their wheelchairs as an example of different issues surrounding that. But most of you, I can see a lot of nods going on out there. Falls often occur related to wheeled mobility devices during transfers. So when the individual is moving in or out of their wheelchair, experiencing a fall can then again result in a catastrophic injury such as a femur fracture that can be severely debilitating. And of course, other adverse consequences. There's a wide realm of reasons that we have accidents related to wheeled mobility devices. Sometimes it's related to a malfunction of the particular device. Something went wrong with the device. Sometimes there's challenges with the design, especially input devices or how that device is operated. User error. User error is common. We all make mistakes. And it's something that we move forward in our realm of patient safety approaches with what we call a just culture. And what that means is it's okay to make a mistake, to err is human, and what we want to do is learn from those mistakes and inform others what we learn from those mistakes so that we can prevent the same from happening in the future. Sometimes there's a communication challenge related to the adverse event, and so it's challenging to read documentation, but sometimes you'll read an issue where somebody had an accident that resulted in a severe injury, and you go back and do a root cause analysis of how did that happen, and it of course comes down to there was a communication challenge between two people, and an individual driving their power wheelchair drove at not quite the right time, and an issue occurred. So communication can be a real challenge as well. And then of course, skills deficits. So individuals who may not have the skill set or may, again, have made a mistake with performing a skill in a manual wheelchair or driving their power wheelchair in a particular area. And this is one of my areas that I see a lot of familiar faces, just strong advocate for wheelchair skills training. And I know that there's limitations in funding and time. We've got to pause and take the time to empower people with the skills that go along with managing their wheeled mobility device so that they can be participating to their maximum function. And when they're able to do that, we're minimizing the risk of injuries related to accidents. Just some examples of, there's lots of different transfers that occur surrounding wheeled mobility. You're all professionals here, but sometimes it's moving from a wheelchair to a firm mat in a clinical setting. It may be moving from one wheelchair to another where there's an opportunity for a challenge to occur. And we get into the more challenging situations of performing a transfer into an overheight vehicle like an SUV. Teaching those appropriate transfers and minimizing those opportunities for the accident is really important. Public transportation is up there, and of course this individual is not transferring while he is being lifted on that platform lift, but this is not a device that he would use as a seat in a motor vehicle. So as soon as we get into the vehicle, that individual now needs to transfer in somewhat of a precarious situation to get into the vehicle seat for optimized safety. And then the one that we are well aware of, but we hear of all the time, falls during transfers in the bathroom. Okay, so moving around in tight spaces, setting up properly for the transfer, minimizing the space between one surface and the other, and really teaching those maneuvering skills so that individuals are empowered to be safe and to minimize the risk of falls during transfers. I encourage you in terms of, we're looking at what is the evidence that's available to support our work in addressing quality and safety concerns related to wheeled mobility devices. Become an expert at searching the literature. It's at your fingertips. Utilize your resources in your medical centers or at your universities and facilities for understanding what the published literature is saying about adverse consequences related to quality and safety with wheeled mobility devices. And this is just one study out of the Human Engineering Research Labs in the University of Pittsburgh that was published in 2016. Really kind of startling findings if you look at these numbers. So they looked at almost 600 people, which is a pretty large subject size for in our area of study. And of the 600 people, they looked at a 6-month period and spoke with them about what types of adverse consequences they had experienced with their wheeled mobility devices in that 6-month period. Almost 64% of them required at least one repair in 6 months. Okay, so that's pretty significant. Almost 28% experienced an adverse consequence as a result of that repair that was needed. And this is startling that 18% of people that experienced an adverse consequence were stranded. Okay, so we work with this population all the time, and if you think about being stranded, stranded could be stranded at home, which is probably best case scenario. Stranded at home, where there's something that's preventing you from being able to leave your home, but at least you're in your environment. I think worst case scenario at home would be stranded in bed because your wheeled mobility device is not being repaired in a timely manner, and so that's an issue. An individual could be stranded as they are beginning to cross the street or in an intersection or out in the community or at school or at work where they experience an adverse consequence where they are not able to get where they need to go. It would really be quite alarming as a result of that. And these were the common findings of where the challenges were with repairs and adverse consequences related to wheelchairs. So for power wheelchairs, not surprising that it's the electric power and control systems. For manual wheelchairs, wheels and casters are the problem. And so when Mark did his introductory remarks and we looked at some of the overviews of where we have device malfunctions and where we're really focusing energy, the caster has been proven to be the weak link. And we're really spending a lot of time with looking at design and improved quality of caster design and caster assembly so that we can address that known challenge that we are well aware of. How many of you are adept at understanding what the standards are that oversee the design and testing of wheeled mobility devices? Some of you are familiar with the standards, not a lot, some. It's really nice to see that. So we have international and national standards. The international standards are kind of the governing oversight, and then each country develops, in most cases, national standards that kind of parallel that documentation for how we understand the design, performance, and characteristics of wheeled mobility devices. And we're looking at things that are really important: safety, performance, durability, reliability, dimensions. So, a uniform system of understanding what does this measurement mean. Device weight and weight capacity is standardized, and then of course a lot of other important measures. The ISO series, the International Standards Organization, is the parent documentation globally. In the United States, we have the American National Standards Institute, or ANSI, and very familiar with a lot of you that are familiar with RESNA, which is the Rehabilitation and Engineering and Assistive Technology Society of North America. Manages our documentation for wheeled mobility devices and related areas like wheelchair transportation safety. We're not going to go into all of the details, but basically the standards outline what are the protocols for testing wheeled mobility devices and how do we report those results so that we have a uniform way to look at what are the parameters for which this device has been tested, and we gain a better understanding about safety, performance, durability, and expectations for the long term. There are variants in terms of where those devices are tested. Some of our larger corporations actually have in-house testing facilities where they can test their manual chairs, power chairs, scooters, across the entire set of protocols and standards in-house. There are also 3 independent test labs in the United States. The Human Engineering Research Laboratories here at the University of Pittsburgh is one of them. And we had a great day yesterday. We spent an entire full day pre-con over at the Human Engineering Research Labs, and were able to look at the testing devices and do some clinical assessment of devices as well. It went very well. So basically, just think about the objectivity of testing. It's great that manufacturers have the opportunity to test their own devices. It helps them to understand where their challenges are, to improve their designs, and to build a more robust product that's going to be safe, reliable, and durable. At the same time, independent or in-house testing is going to be kind of biased towards that particular area because it's their product. And we always encourage the next step or the support for objectivity is to have the device tested again at an independent laboratory that does not have a relationship or a conflict of interest with that particular device, so that you're getting objective reporting and information there. Just very quickly, within the wheeled mobility standards under RESNA, we have the WC1 and the WC2 documents that provide comprehensive overview of how devices are tested, manual chairs, and then we go into section 2 that is more specific to some power mobility controls. And then also to highlight that there are a separate set of standards that are related to wheeled mobility devices that are used in transportation, On Friday, there's going to be a great session specific to this topic, and I encourage you to attend that if you're interested. But basically, we're looking at when a wheeled mobility device is transported in a vehicle or when it is being used as a seat in a motor vehicle, that device needs to be crash tested. And on the University of Michigan Transportation Research Institute website, they actually provide a list of wheeled mobility devices that have been crash tested and passed those requirements for being used as a seat in a motor vehicle. I encourage you to take a look at that. We have so many clients that are using their wheeled mobility devices in transportation situations, and we need to be aware that there's a small percentage of our devices that have actually been crash tested. And so it can really guide your decisions in promoting safety and support for your individuals to know which devices are appropriate for that particular application. I don't expect any of you to be able to read that. I can't read it from here. I just wanted to provide an example that the FDA, so in the United States, the US Food and Drug Administration regulates wheeled mobility devices as medical devices, and powered wheelchairs are considered Class 2 medical devices, and they reference a set of what we call consensus standards. This is so far away. Consensus standards. So the FDA recognizes the ISO and the RESNA set of protocols and standards for testing devices, and then recommends that devices be tested as a component of the FDA clearance for marketing to use these devices in the public sector. Okay, so it's just kind of an overview that we have that recognition. And here's an example of just kind of highlighting what are some of the things that we're testing and measuring. And when you look at things like device measurements, mass, maneuvering space, what's the ground clearance? Really important to know if it's a 1-inch ground clearance or a 3.5-inch ground clearance. It's going to impact the environment that you're functioning in. And you can look at all of these key pieces. So the range, you know, how far does this device perform on the single charge of a battery? You can read a glossy brochure, you can read the website, and it will say it has a range of 12 miles. Well, my question is, how do you know that? Did you test it? Because if I'm going to send an individual out into the community and I'm expecting and I'm telling them you've got a range of 12 miles, which means 6 miles out and 6 miles back, I want to be confident that the device has actually been tested to perform that way so that we don't create a situation of somebody getting stranded or having another adverse consequence. I show this particular example of this wheeled mobility device because it's just one of many that have been cleared by the FDA as a Class 2 medical device. They have been tested to all of the standards that are required for such. And just provides an example of what we can expect. And I really encourage you to become familiar with what those standards are in at least a general sense. And to ask the question, when you're presented with a wheeled mobility device, the question is, has this device been tested? That's the first question. Second question is, what was it tested to? Okay, you can ask for that set of standards. Third question, did it pass? Did it pass? It's alarming the number of devices that, yes, have been tested, but the next step is, did they actually pass the test as recommended? And sometimes that question is no. And the final question is, would you mind sharing a copy of that test report, please? And when you get the answer that says, no, we'd rather not share that, that can be a red flag because there might be a reason that they don't want to share the objective results of their test report. I just show, again, another example. This is a company out of Vancouver, British Columbia, PDG, and just a commendation that their devices have been tested to the International Standards Organization requirements, and they post all of their independent lab-reported test results on their internet site. And so I think it just lends a great model for where we should have access to test reports and become adept at reviewing at least a pass-fail type of recommendation so that we are ensuring that we're providing devices that have been proven to be safe, durable, effective, and perform to the expected standards for that particular device. Talked a little bit about the United States. Basically, just a quick review is that devices are regulated. Our wheelchairs are regulated as medical devices. Sometimes that's a new concept for individuals working in this area. And just a quick comment about coding. So in the United States, the Medicare, the consultants that are hired for the Medicare Pricing Data Analysis and Coding Contractor, or PDOC, basically reference performance standards and results to assign a HCPC code. I see a lot of nodding heads out there. to assign a HCPC code that ultimately moves that device into a category or group for power wheelchairs anyway, group 1, 2, 3, 4, 5, based on the characteristics of that device. And so for each of those different areas, Brad will go into a couple of the details. There are minimum criteria that must be met for that device to be coded in such a way. And the coding then impacts the payment system and reimbursement for that particular product. And so we'll go through some of those examples so that we're trying to support you to understand why is the regulation and testing and oversight of wheeled mobility devices very important for the work that we're doing in supporting our clients. So from there, Brad will give an overview of how we apply some of these specific concepts for standards and testing and regulation and oversight to wheeled mobility devices specifically.
So there is, after all, a method to the madness with coding. So there is some rationale behind why devices are coded in certain ways. And so when we think about the performance on standards and how it affects what code or what abilities a device has to perform in a certain way, we also have to think about the flip side, the limits, what the device can't do. And so that's why we developed the CLOUT tool, was to help you identify the limits of use of devices in certain situations. So when we're thinking of those limits, we want to think of them comprehensively. So we want to think about the descriptions and features of the device, the different scenarios that we're going to use the devices within, the regulation and coding, like Kendra mentioned, what test standards exist, what test standards don't exist, the performance expectations of the device, the way we care for it, maintain it, store it. Those can certainly be limits for some people. The training requirements, how do you teach people how to use it? And so all of these different aspects of limits help us identify where we can do further testing to define abilities and limits of our devices, and then allow us to determine ways that we can mitigate those limits so that we can use the devices in scenarios that are safe. So we'll go through a few more specific examples. But to give you some visual help as you're going through the guide, we came up with a way to make the dashboards and tools in the document easier to read. So we use some color coding. So red in the document means common products in that category do not typically have that feature or are not typically clinically appropriate in that scenario. So think of it as a red flag. Yellow is sort of in between, caution. A limited selection of products in that category typically have that feature, or common products in that category have limitations and may not always be clinically appropriate in that situation. So you have to use your judgment or look at only certain models in that case. And green is more of a green light. Most or all products in that category typically have that feature, or the most common products in that category are usually clinically appropriate in that scenario. So with that in mind, this is kind of an idea of what the dashboard looks like, and we'll go through some examples of how you can use those dashboards. So we'll talk about power wheelchairs first. So as we know, there's 5 groupings in terms of coding of power wheelchairs. And this graph gives you an example of, on the top, your different groupings of power chairs. On the left-hand column, you have the results of the standardized testing. So the test performance measures have identified the dimensions of the devices, the obstacle height that they're able to climb, the minimum range that they can go on a full charge. So if you charge up the battery, how far can they go? And the way that the devices perform according to those different features, or the way that the device's dimensions are, define what category those devices will fall into in terms of groupings. So you can see some very significant differences between the different groupings of power chairs. So this gives you an example of the way that we can look at device features on the left with respect to the different groupings of power chairs at the top. So we have group 4 power chairs on the top left, and it goes towards group 1. And you can see as you move from group 4 to group 1, we go from lots of green lights to lots of red lights, right? So it's giving us ideas of where there are more limits as we move through the different categories of devices. And so device features might list things like, does the device allow you the opportunity to add multiple power seat functions so that we can do things like relieve pressure? Or how far on a battery charge can the devices go? And if we zoom in a little bit further, we'll see here that we have, we're looking at just some of the device features. So let's say, for example, we think that our client needs to be able to stand in their power wheelchair. Well, clearly we can see that our Group 4 power chairs are the only device category where we have that option. The other power wheelchair codes have limits and are listed in red there. And here's another zoom in just looking at Group 2 power wheelchairs. And so one of the learning objectives was to look at Group 2 power wheelchairs specifically and understand the limits of their use specifically as an example. So we see that Group 2 power wheelchairs have a minimum top speed of 3 miles per hour, a minimum range of 7 miles on a full charge, obstacle height climbing ability of 40 millimeters. They do not have drive wheel suspension, and the dynamic stability incline is 6 degrees. So if we think about those device features, where do we see clear limits in their use for certain clients? Does anyone want to yell out some limits that we have with using Group 2 power wheelchairs? Outdoor mobility, right? So the different feature, the things that distinguish a Group 3 from a Group 2 provide a little bit more limited outdoor mobility for a Group 2 compared to a Group 3. What else do we see? The ability to add power seat functions, right? So there is a category of Group 2 chairs where we have an option to add 1 power seat function, but there's also Group 2 power wheelchairs where you cannot add power seat functions. So that's definitely a limit for some of our clients who need those features. Anything else? One more example. Battery range is another good example.
Good.
Alternative controls,
Yep,
right?
absolutely.
So if you have a client who needs multiple different types of alternative controls other than a standard joystick, then Group 2 would certainly be limiting for that client. So we provided the information visually in these dashboards with color codes to try to make it easier, but we've also provided text descriptions. So here's an example of how we've written it out in text to help you. So a Group 2 is defined by performance characteristics indicate that the Group 2 power wheelchairs are most appropriate for indoor, home, or community environments for limited distances. While maximum overall dimensions are 48 by 34 inches, some models are modular, which allows for disassembly for stowage and transportation. We also provide some more detailed descriptions. This is an example of the Group 2 power wheelchairs that have the no power option to add power seat functions. And I'll break this out into bullets for you to make it easier to read. So this summarizes the limits of using a Group 2 power wheelchair. Lacks an expandable controller, no ability to add alternative controls. No power seat functions. This restricts use to individuals who can ambulate to some degree, can transfer in and out of the device, and can relieve pressure independently. Otherwise, they would need the power seat functions. It also limits the use to those who do not need seat functions for standing or other physiologic purposes. They cannot be used by those who use a ventilator because that can't be added to a Group 2 chair. There's limited use outdoors. They're not ideal for full-time users who need to traverse varying indoor and outdoor environments or inclement weather. Only some models can be used as a seat in a motor vehicle. Only some models can be safely secured unoccupied in a vehicle. And only some models disassemble for stowing. So this really helps you understand the limits and the way that you can use devices in this category, and it can also help you with justifications when you're writing explanations to the insurer about why your client can't use this category of device. And of course, we have a similar description for Group 2 chairs with power options so that you can add a power C function like tilt. And just to be complete, we've created a dashboard also for manual wheelchairs and one for power-operated vehicles or scooters. And we'd like to point out how much red is in the dashboard of the scooter.
Right.
And I'll pass this back to Kendra.
Yeah, so basically we were just providing some examples. Again, it's a very comprehensive document. We want for you to be aware that it's available to you. All of the details are there. So if you're sitting there going, I'm not quite understanding how that test applies to durability testing, the information is there to support your understanding. One of the examples, as Brad was showing kind of some zoom in types of looks at coding of power wheelchairs, is we have particular tests like for durability as an example. And there's 2 specific tests that we do for durability. They are designed to simulate kind of everyday use over an approximate 5-year period or the equivalent there. One of them is a curb drop test where literally the device, the machine, picks up the chair and drops it, picks up the chair and drops it. The minimum passing criteria is 6,666 curb drops without failure. There's another one called the double drum. And basically, it just moves it over kind of an uneven type of terrain situation that's kind of for everyday mobility. And the device is expected to last for 200,000 cycles on the double drum test without failing. So those are simple types of measures that you can ask for those reports and make sure that they are meeting that absolute minimum criteria for durability over the lifespan of the device. How much weight do you put in the chairs? All of the protocols are established for testing the device to the maximum weight capacity that's been identified for that particular device. So it's actually loaded with what we call a crash test dummy or a test dummy. We've moved into calling it a mannequin so that it's loaded. If it has a 250-pound occupant mass capacity, it's tested with a 250-pound dummy, okay? We've spent a lot of time talking about objective information and how do we collect data and how do we know that this device has been tested to appropriate standards. That's just one component of assessing wheeled mobility devices for performance, durability, and safety. The second really important part is our clinical testing and our clinical assessment of these devices. And what that is I love saying, get in it, drive it, push it, wheel it, put it to the test. If it's intended for outdoor use, take it outdoors, okay? The other thing I like to think about is kick the tires. You know, really get into this device and figure out if it's doing what it's intended to be doing. So it's an essential component. It's complementary to the laboratory testing that we've been highlighting. Optimal when there's a team approach, more than just, physical therapists or OTs. Bring in your rehab engineers, bring in your technicians, bring in your suppliers that have a different perspective on the performance of the particular device. We often use in rehabilitation what we call an activity analysis framework to gain an understanding of what it takes to do something. So when you think about a task or an activity and break it down into what is required to perform that activity. Is it performed in sitting, standing, laying down? How much muscle strength is required? How much coordination? How much balance? How much tone might impact that particular application? Allows us to break down that activity and understand what it takes to perform it successfully. And then we look at the clinical evaluation in 2 different places. Number 1 is kind of in a controlled clinical or even laboratory type of setting, depending what you have. And then the second one is in the anticipated area. So in that big diagram that Brad highlighted, anticipated usage scenarios was one of those. In the controlled setting, so it's in your clinic, it's in your workshop, it's in your lab, whatever you might have. We're looking at how do you put it together and take it apart? How does it interface with the person? So seating supports, postural corrections, skin protection, some of the issues that Brad highlighted that were available to you in the dashboards. How does the person get in and out of it? There's going to be unique features, there's going to be limits of use based on the design of that device and how an individual can safely get in and out of it. And then we talked about the controlled usage in an indoor setting, care, maintenance, and storage. And I encourage you to also be evaluating the instructions for use or the guidance that's provided for how you use this device effectively. It should be thorough. There are standards that dictate what must be included in that information, and we want to make sure that the information is universally available to individuals who need it. For example, we've seen some examples of instructions are provided by a DVD with a video display of what you need to do with nice elevator music in the background, no voiceover, no zoom in, and so an individual who has a visual impairment or isn't able to follow that closely would never be able to assemble the device without assistance. And the second area with clinical testing of wheeled mobility devices is in those anticipated usage environments. So again, if it's intended for use in other types of settings than a controlled clinical setting with 12-inch tiles and smooth surfaces, get into those devices and get them out into that environment. We encourage this type of approach, not only for devices that might be presented to you by a manufacturer's rep. We've got the latest, greatest wheeled mobility device, and all of your clients should have one. You're going to jump in that device, you're going to drive it, you're going to push it, you're going to kick the tires, you're going to ask for test reports, you're going to ask for the performance data that's available. But also think about the devices that are coming in that you're getting ready to issue to the individuals that are coming in. It's always a good idea to get in it, drive it, test your programming, make sure that in a manual wheelchair the alignment is appropriate. If it's going to pull to one side, you're going to feel that right away, and you can make those corrections if possible before the client arrives for their issuance. We're also looking at what are the requirements for stowing the device in a vehicle, and what are the opportunities for using it either occupied or unoccupied in a transportation situation, whether it's in their personal vehicles or in public transportation, getting out and about. And oftentimes, as a result of this approach, we're going, I looked at my objective data that's available kind of on paper or electronic. I've gotten in it, I've kicked the tires, I gained a lot of information, and now I have a short list or sometimes a really long list of more things that I want to know about this device. So again, just some examples. This is looking at a situation where we were looking at some national contracts, big business for wheeled mobility devices. That's my contracting officer. We said, hey, why don't you get in and get a sense of what this feels like to use a scooter. We took it outside to initiate our preliminary testing. The device was specified as being able to be used on mild outdoor terrain, something like a grassy situation with a mild incline. So this is an unimpaired person who's actually just putting that device to the test to see how it performs in that particular situation. I love this video. Look at my disclaimer. I covered that up with the red box so that I really don't want to defame any particular company for the problem, but you got to test these devices. So here's a device that cleared by the FDA. Here's our test report. Everything passed. We're good to go. And then it's like, great, let's get in and kick the tires and see how it performs. I'm going to show it to you and see if you see what's going on here. I know it's hard to see. What do you guys see? See the left tire? So here's our testing, right? This is highly sophisticated. The shadow is me with my hair up, right? And I'm in a scooter behind that scooter. I see some colleagues in the audience that participated in these adventures. But I'm just going to show it to you one more time. Watch the left wheel. So this is iPhone video with me in a scooter, chasing that scooter, just to see what's going on. We never would have seen this had we not done our assessment. Here it is again. Look at the left wheel. I know you guys are way in the back. Do you guys see it? Okay, and so we were able to include that as a component of our device analysis to determine where we might have some challenges and factor that into the considerations. Obviously, if this device was going to be issued to an individual, you would want to have that looked at very closely and have the corrections in place before you issue that device. When we're looking at clinical testing of wheeled mobility devices, again, we've talked about some of the standards. This goes right into all of the pieces, so kind of a repeat list of things that we are looking at and just showing a representation. This was a project that we actually said, let's put this device to the test and see what we might be able to find out. The reason we specifically chose this particular device is that these devices are marketed. They're available. These are kind of the equivalent of an all-terrain power wheelchair. You know that a lot of our clients are asking for them. They want to know more information. And we used it as a very specific and kind of fun example of how we can put this model to the test of looking at our objective data and matching that with the clinical device evaluation. And so obviously this type of device is not intended for indoor use. And so we said, let's get it out there and see what it really can do. I will be honest, and having worked in this area for a long time, I would consider myself a skeptic with like, should we be putting people with disabilities in these types of chairs that are specifically designed to allow them to go to the middle of nowhere through mud, gravel, muck, snow, whatever might happen. And I was skeptical, but this is an example of I got in it, and I've been in a lot of these devices and really have put them to the test. My mind shift has changed in terms of understanding that we now do have the ability to support people with very severe disabilities to go places that they really have not been able to go before. I'm an outdoor enthusiast coming from the great state of Colorado, and I just choose to evaluate these devices and make recommendations so that we can support them to be safe and effective, to allow people to do what they want to do. This is just an example. This is a video on the right here of how these devices are designed to function. That is a running river. She is intentionally submerged a couple of inches, and then she's gonna traverse up a packed sand environment. She gets a little bit stuck there, and just shows an example of what these devices can do. This is a component of our assessment of this device. So we did all of our controlled clinical laboratory type of assessment. How do you get in and out of it? Can you use it indoors? No. Can you, where do you need to store it? What are the requirements for using that device? And then we took it outside in the type of intended environments. I'll show you a couple of quick videos, but this is a wet, grassy environment down a pretty significant slope. Slopes never show well in a video, but he's doing a 360 on the slope and just kind of showing how that device is intended to function. I love the bottom left. Why take the trail when this device is specifically designed to blaze its own? And so really can traverse a lot of different types of environments. On the right, what we're doing here with Ben on the right is he's testing the effectiveness of the brakes. One of the standardized test protocols in a laboratory setting is to ensure or test the performance of the brakes. And what he's doing, you can see, it's hard to see the slope, but he's coming down a pretty significant muddy slope and then letting go of the joystick controller and seeing what happens. And it's hard to see it a little bit. You see a little bit of a pitch forward, right? You see him kind of pitching forward. This is, a day in the life of test engineers at the Human Engineering Research Labs. We were out there yesterday. I probably had 6 people say, how can I get a job here? So incredibly awesome. So this is one of our lead engineers, Garrett, navigating a muddy pit. And I know they're kind of small. I would have made them bigger if I knew I was going to be on this huge screen. But basically going through a couple of inches of a muddy pond. And the reason that we tested in these particular situations is if you go to a website for this device or anything similar, it's what it's marketed to be able to do. Yet, when you look at test standards, and I said that they are used to simulate kind of everyday usage over about an approximate 5-year lifespan, that's kind of in the situation. I'm gonna go to Ben, because Ben watched Garrett. Motor learning at its finest. He takes the high road and is successful on the first go-round. So there you go. But when you're looking at those tests in a laboratory setting, it's really kind of for everyday intended use. Cruising across a community environment, the range is 12 miles. For this particular device that was tested in that laboratory type setting, the tested range was 6.3 miles. Now we're out in the wild blue yonder here, and we want to have a better understanding of how it's going to perform. And so we put that to the test and took a look at some of the obstacles and some of the environments. And in this type of application, you would expect the range in this type of terrain to be less than a laboratory established range for a charge on a single battery. And this is absolutely my favorite, the last one. He's coming over a significant log pile. Then these folks are test engineers. They are not impaired in any way. But again, if your clients are asking for these types of devices, there you go. And this is even fabulous. Now he sits down and he comes down. You'll see what he does. Oh, seatbelt might help. No. So it just gives an example of, if it's intended to be used in a certain way, I have some questions, and I want to know if it's really going to work well in that particular way. Again, identifying limits of use should not be viewed as a negative term. Limitations, is often viewed with a negative connotation. It's not the point. Bottom line, it's the facts. What are the limits of use of this device, okay? When you identify that factual information, it then allows you to understand what are the appropriate circumstances for using this particular device, could be a Group 2 power wheelchair, or based on the limits of use, it's not an appropriate device, and then that supports your justification for providing something different. In this particular application, these are some of the limits of use, okay? Limits of use for indoor mobility. Drive control interfaces, this particular device can only be driven with a joystick, okay? Cannot be used with an expandable controller. We have limitations for seating surfaces, okay, and options. We don't have the option for power seat functions other than power standing. So in this particular application, do you think that power standing is for preservation of bone density and pressure management? I think it's for like casting a fly rod, right? Shooting a gun. That's really what it's intended for, but we have to be cautious in that the individuals that we're working for that have significant physiologic and physical impairments are now provided with a device that they can stand up in. And we just want to make sure that we're following that medical model for looking at all of those issues appropriately. Transportation is a challenge, getting in and out of it is a challenge, storing it. So if it's not intended for indoor use, I guarantee you it's not going to make it through the door of most indoor facilities. You're going to need to store it somewhere outside. So that means a garage, a shed, a barn, whatever you got, but you guys know these topics well. I've got to have a power source, and I have to have some sort of temperature management to manage this device as well. And then I throw in there the service delivery process, because when we're looking at devices that have exceptional types of features and functions, we want to make sure that we're implementing the same service delivery process that Brad highlighted at the beginning, where we assess clients. And we move through a strategic approach to get them the right technology, adjust it to them, train them how to use it, and set up systems for care and maintenance. So regardless of that system, we want to make sure that we are doing the same. By identifying the limits of use, it gives the opportunity to then mitigate. We can use the word mitigate the limits of use to come up with a solution that provides effective operation, optimal performance, and safety. Sometimes it's an adjustment with that particular device that you're working with. Sometimes it's more training, education, and support for the use of the device. In other situations, this is not the appropriate application here, and we're going to look at something else entirely. So again, it creates the opportunity for what we need to do. When we look at identifying limits of use and then the options for mitigating limits of use, it does support us to provide the right technology. It can impact what you're buying. And so the example of the scooter assessment, this is going to be a big potential purchase for a large healthcare organization. By doing a comprehensive analysis, we're gaining objective information that guide procurement decisions, what we're going to buy either for a single individual or for large numbers of people. It allows us to identify needs for further testing, promote solutions, and also, identify where do we need more training. I mean, I'll tell you, and delving into just kind of this sidebar of these enhanced performance devices, I've had to learn a lot. And what it teaches me is that these are not everyday devices, and every time something new is presented, the other question I ask is, what's the learning curve? What's the learning curve for we as clinicians and suppliers and providers? And then how does that learning curve for me transfer over to a learning curve for my client? And that becomes a critical component of, is this the right device? What's next? So where are we? This was a great project. We had a blast. We had a fabulous team that I highlighted. We really feel like we took a compilation of a lot of our collective experience to provide a summarized document that we think is meaningful to your practice. Version 1.0, we're just getting started. It's a draft. We want to move forward into refining the current document, capturing information, updating as needed, adding sections for power add-on devices, which we currently don't have, enhanced function devices, which we have not specifically specified, and also thinking about sports wheelchairs and technologies. We have a lot of deficits in that realm of sports wheelchairs and technologies because they are not regulated the same as wheeled mobility devices for everyday use. Is that crazy or what? It's a wheelchair, it's a basketball wheelchair, and they have completely different sets of requirements, or in some cases, minimal requirements. So we're looking at that. And then we're also looking at, again, right now it's a PDF document. I encourage you to look at it online. You can have a printed copy, but the font's really small. We want to expand that and ultimately have an electronic system that's a portal where you can go in and click radio buttons with, what am I looking for? What are my activities? Body systems, structures, and functions. what is my environment, and be able to identify limits of use of groups of technologies, and ultimately take it down potentially to a device level specification where you could say these 3 devices might work great in that particular application. So if you have any interest in being involved in kind of next steps, we haven't mapped it out, but we're thinking about focus groups, we're thinking about looking at some funding opportunities, and really growing this for our industry so that it's a useful tool across the board. We think that it has great potential. Other areas that we're thinking about and kind of looking at this, we, in this room and with our work group, extensive experience working with wheeled mobility devices, and we feel that we were able to kind of look across the span of hundreds, if not thousands of devices and categorize them appropriately and identify methods for evaluation. I put this up as kind of, what about those exoskeleton technologies? We work in that realm as well, and we're learning about that device and how they are appropriate for our clients who are wheeled mobility device users, and is the same intended audience for the exoskeleton devices as well. These are 3 of the 4 devices that are currently cleared by the FDA in the United States, and it's just an example of like, let's start with 4 and categorize devices based on features, functions, performance expectations, safety considerations, and then matching clients to technologies based on features, functions, descriptions, testing, and limits of use. And we should be able to do that fairly simply with straightforward devices and then expand that as this technology expands. The website is available, like I said, for download. It's www.patientsafety.va.gov. You go into the professionals tab, but like I said, you can Google CLOUT wheelchairs and it'll be at your fingertips. All right, I know we took it right up. We used our full time, but we're going to go into the lunch break, so if anybody has any comments, questions, I don't think we have a microphone, so please stand up and shout out comments, questions, suggestions. We'd love to hear from you for a couple of minutes, and then we'll break for lunch. Anything out there? Yes, Mark Warner. Very good question. So Mark asked, since repairs have been identified as such a significant problem, does the CLOUT document take into account warranty considerations and past performance? Yes. So in that section on quality and safety, there is actually a recommendation for looking at what is the warranty on the device, what does it cover, and it's always helpful to look at past performance of the device. And when we looked at those objective pieces of information, not only can you ask that company for their test results, which is an objective piece of information about performance, encouraging you to look at the published literature. We have published documentation out there that says, do these subset of scooters really perform to what they were reportedly tested to? And we find significant variance. So looking at all those pieces, Mark highlights some great considerations with how has it performed in the past and how does that tie into performance, durability, and safety as well. Okay, go ahead. That's fabulous. I love your question. So he said, did you look at the tech RMD? I'm looking at a few colleagues out there. We've picked it apart, okay, a couple times. I think picked it apart in terms of what is it? What is it? And has it been tested? And what are the results of that test? And what is it great for? And what are the limits of use? So for those of you who are out there, New Motion is the distributor in the United States for the tech RMD. It's a product that's imported internationally, and we looked at it. It's been tested to ISO standards. All of the test reports are available. Something that stands out to me is it has a 1-inch ground clearance, so that's just something to be aware of, depending on the application that it's usable. I think it's going to work fabulous for some people, and it's going to have limits of use that don't work at all for other people. I'm glad that you brought up a specific product or topic, because what I encourage you to do, and I know this is all getting thrown out there, and you're like, what is she talking about? What is Brad even saying? We wanted to introduce the topic. I think that you can get the concept of we have objective information, additional subjective information from getting in those devices and testing them, and think about what does it do, what do we know about it, what are the limits of use, and how does that impact my product selection for my client. So when you're working that exhibit hall this week, be thinking about that framework for evaluating devices. And it's not that this device is going to work for everybody or this device is going to work for nobody. There's a technology match for each individual, and the model of identifying limits of use and the opportunity to mitigate those limits of use will support you to identify optimal solutions for the folks that you care about so much. Okay.